Good afternoon, everyone. Today I am going to discuss about the embedded system concepts. I am from PG Department of Computer Science, Dr. V. Krishnamurthy. In the embedded system, we are go far before the microcontroller. In the microcontroller is playing a major role in embedded system. So microcomputer and microprocessor and microcontroller. So here some differences are there. So in microprocessor, the instructions are received and then transferred to the controller. In microcomputer, as a functional process will be displayed. So here in the microcontroller is already programmed. It's like a motherboard. So previously in the microprocessor, 8085, 285, 286 are there. In controller, in 8051, 8251, these versions are available. See, these versions are used to make the programming is very easy. That means the instruction will transfer to the device to device, and the instruction is transmitted to the one device to another device. The process is happening. So like a SysKnife with multiple functions incorporated in the integrated circuitous. Single knife is we are taken to perform multiple tasks. Okay, see here the microcontroller is happening. Classification of microcontrollers in the earlier, so various versions are available. In 1970s is introduced in the Intel 4004. So first 4-bit is specified. After that it is transformed in 8-bit, and then after that ROM-less 8-bit, that is 8048, 8031, 8051 8-bit masked ROM is introduced in 1980. After that Microchip Pixel 8-bit 1985, and then Motorola, and then versions are come there. So in the growth of the evaluation of the microcontroller, so we are going to discuss in the 8051 series in the updated. So here we are going to discuss about the architecture of microcontroller. In the architecture of microcontroller, having the different functional specifications are available. So here in the 8-bit microcontroller 8051, possible the functions read, write and process of 8-bit data, and mostly here we are specifying various applications we are using. There is a robotic functions are using here. This is the internal structure of 8051. This is the internal fixed structure of 8051. Here external interrupt is available, the functional specification, and then there is an external interrupt as received, the interrupt controller. Interrupt controllers transmitting various type of interrupt controls are available. We are going to discuss, and then it will transfer that in CPU, and then oscillators are connected with that CPU. In the oscillator, two types are available. We are going to further definitions we are see that. And then 4 kilobyte ROM is connected to the bus control series, and then 128 byte is connected to the input output port in bidirectional, and then timer is specified for the functional specification. There is a input value. That value will be bidirectionally connected to that, and also connect to the CPU. There is a serial port, transaction and receive, transfer and receive processes are available. In the input output port is port 0, 2, 1, 3. That means 0, 1, 2, 3 up to 4 ports are available. So 4 ports taken for bidirectional, and then it is connected with the address and data buses. And then bus control are also available. The bus control is transmitting the data, that is permanent values, and data storage is possible. Here in the CPU, performing all the whatever the input signals we are receiving, what is the input controls we are receiving, that value transmit to that particular specification, so maybe in a memory or it may be at some specified locations. And then after that, the functioning is, user has no power of the functioning in CPU, we are taking for that, in that internal process will be taken for that. See here, in the interprets program printed storage spaces specifying in random access read-only memory and projected only the data will be stored in that particular specifications. And then oscillator in the microcontroller specifying for that piece of equipment, that means here we are taken for slices of the values. Okay, see here 8051 consists of on-chip oscillator that here on-chip oscillator it is interconnected for that. In the interconnections process will be any one oscillator will functions. Okay, so that is at the time of source the signal will be received in the CPU. Both are connected in the oscillator and CPU. And then buses in 8-bit buses also while where it means microprocessor and microcontroller also 8-bit buses here we are using here. In the bus control structures we are 4 pins only we are connecting here. In the fundamental bus groups of voice is connecting maybe in 8 or a 16-bit. 8 or 16-bit process are used for here we are using for that. There are here we are seen that previously in the diagram 2 buses are we are going to use. One is address, another one is a data bus. Address and data buses are while direct means we are sending the data and receiving the data via the address and data buses. And then another one is interrupt in the architecture. Interrupt in the interrupt is a specific function. Interrupt is a specific function. In the function is working as a transmission process. That is user input is received, and then that input will be transferred to the device. That means here in the interrupts here we are specifying 5 types of interrupts. INT 0, interrupt 0, interrupt 1, and then TF0, TF1 or receiver or transmitter 1. So 1, 2, 3 and 4. The 4 interrupts are here, and then in addition in microcontroller we are taking for the R1 or T1 is both. These are all the interrupts are we are specifying vector interrupt. In the memory here we are seeing that already read-only memory and then random access memory, both permanent as well as secondary storage also available. See here in the data memory of 8051 is used for data temporary storage because and the controller is only for transmitting the signals to the particular nodes, or it may be a execution of the process. So it does not store any data internally. The data will transfer to that particular memory storage. Okay. So here 4 kilobytes of core memory, that is programmable memory, that has ROM and 128 byte of RAM is available. And then here input and output we are using that externally initiated values, that is interrupts we are receiving. In that interrupts we are taken, and then that value will be transferred to that port as well as the devices. And then timer and counters we are using here always we are specifying only for 16-bit counter we are using for here. These counters are divided 8-bit only. Then next we are going to discuss pin architecture of 8051. In the pin architecture, totally 40 pins are available, same like at 8085. There is a microprocessor having the same 40 pins, but some differences available in this pin architecture. that is here in the 8051 is for transmitting the data, that is the signal will be transmitting. In the processor, whatever the initiated operations we are initiated, in that operations are performing in that microprocessor. Here controller is here 0 to 7 processing, that is 1 to 8 is a while, and then after that restart instruction is we are specifying in the 9th pin. After that transaction and then receive data, transaction data, receive data, here 10 and 11. These pins are we are specifying interrupt 0, 1, 2, and then timer 0 and 1 is we are specifying, and then read and write operations also a while, and then crystal 1 and 2, and then ground we are specifying here. And then this is for the left hand side, and the right hand side in the pin is in the 20 is a ground, and the 5 volt is 40 is a 5 volt, and then 21 pin is 21st pin is we are taken for address bus, here higher order address bus A to A15. A to A15 is up to 21 to 28 is higher order address buses available, and then 39 to 32, 32 to 39 multiplex address and data buses are available. So here 32 to 39 is we are taken for higher order, lower order address and data buses are available, and then here address latch enable, and then ESN, and then EA are 29, 30, 31 is we have in the pin. So total pins are in the total 40 pins. Addressing we are taken for higher order address and lower order is 16, 16. Total 8-bit, 16 is over, and then program initiated is 8-bit, and then interrupt is 4, and then crystal is 2, and then transaction data, receive data is 2, and then read write operation is 2 pins is there, and then enable address latch enable external pins are here we are specifying, that is PZ is we are 1 pin is there total, and then ground and VC is 1 pin. This is for the explanation of pin, various pins we are discussed now. The pin is the pin 1 to 8 is recognized as a port number, and then pin 9 is made as a reset pin, 10 to 11 is a port 3 supplies the number of transaction data and receive data, control indicator, and then read and write memory process, and then domestic pull and pull up port with the quasi bidirectional with the within the pin, and the 18, 19 are acting as a crystal pin. This is the 18, 19 crystal pin, and then 20 is the ground, and then 21 to 28 is port 2, other than the serving as a input output port, and then 29 is store enable, program store enable, 29 pin is program store enable, and pin 30 is for external access EA, external access pin is we are specifying. 21 to 28 is port 2, 21 to 22, 28 is port 2, 29 is program store enable PSN, and 30 is external access, 31 is address latch enable ALE, and then 32 to 39 is lower address and data buses is multiplex, and then pin port 40 is 5 volt power supply, direct current is there. And then next we are going to discuss registers. In 8051 there are various type of registers available. Here 34 general purpose or working registers are available in 8051. See here in the accumulator, and then D register, stack pointer and program counter, and then program status word, and then auxiliary carry flag, parity flag, and then sign flag, overflow flag, and then counter and counter serial data buffer time registers are there. See here, these are all with a general purpose register in 8051. And then one more is while in 8051. Here oscillator and the clock is we are using to transmit and receive the data within the specified time duration. The process will be executed. See here the external oscillator circuit is we are specifying in the pin oscillator is we are specifying in 18 and 19 pins. So here see here 1 second delay we are taking for that each instructions for oscillator circuits. See here one machine cycle in processor we are calculated 0.0103 millisecond like that. So here machine cycle is taken minimum simplest machine cycle for one instruction. So consists of 12 crystal cycle, 12 crystal pulses here taken for that. That means digital specification 12 crystal pulses we taken, so one instruction will be executed like that. So first is crystal 6 pulses used for opcode, remaining open. So total 12 crystal pulses we taken. First 3 is opcode, that is the operand code, operation code, and then operand. Whatever the value we are going to perform for that. So this is given effective machine cycle process, that is a 1 million instruction per second. And then memory organizations, here we are using the maximum 64 kilobytes in a code of the instructions we are going to perform in the particular durations. Okay. And then input port, and then port circuits are we are using in the 8051. And then 8051 various type of instructions are we are using. Here the 5 type of instructions are we are using in the 8051. So first one is data transfer instruction, and then arithmetic instruction, logical instruction, branch and loop instruction, and then bit manipulation instructions are we are using for in the 8051. So now we are going to discuss in the before that these instructions are we are following in the addressing mode formations. There are various type of addressing modes are available. Why we are going to use addressing modes? The addressing modes is very important to construct and transmit the data to the next flag registry, or it may be a register wherever. So we are following different type of addressing modes are available in both the processor as well as the controller. So here immediate addressing, register addressing, direct addressing, indirect addressing, register specific, indexed addressing. These are all the addressing are available in 8051. These addressings are used to perform the data transmission process to register to register, register to memory, or data to data. So 3 ways we can transmit the data in the addressing mode process. So here in the first one, immediate addressing. So we are specifying where the location we are specifying. It may be a memory, it may be a register. So it may be a accumulated process where we are going to transmit the data immediate itself without no need for the registry, or it may be a specific storage devices. So we can send the data in providing us for the instruction itself. Directly we can transmit the data. See the example. See here, this is for the opcode, this is for the operand. 30 hexadecimal numbers move into the accumulator. See here, and then we are going to perform the addition operation. So whatever the value already we are sending to 30 hexes we are sending to the accumulator, and in that value accumulator is available 30 hex. We are going to perform an arithmetic operation, that is as 83 we are going to add it in the data and store it into the accumulator, then the value will be moved into that particular location. So this is where you don't need to specify any register location. So we are directly passing to the data to the accumulator, and then we can perform the addition operations or move operations. This is for immediate process. Then the register addressing. In this register addressing, we are going to specify in that particular register which address we are going to store. That specification is we are going to specify that data where while we are going to find out for that. So that address we are specifying. Example here while say register 0 contain that value we are going to move into the accumulator. And then another instructions here, add operation R0 to R7, R0 to R7 value while in that value move into the next register. So that means we are going to select for the particular value to that location, that is the memory location. This is for addressing mode specifications. See direct addressing. So we can specify the where we are going to specify. Okay, this is for the addressing mode process. Okay, thank you.